Today we're going to do a lab, the problem of which is to find the velocity of a toy car on a flat horizontal surface. It would make sense to make our flat horizontal surface the floor of the school. Find a good flat part of the floor of the school and use that as your surface. Okay? We want to find the velocity of a toy car as it moves along at a constant velocity on that surface. Now, here's how we're going to do it. This is different than anything you've done before. In Science 10, you probably plotted position time graphs to find velocity, but you probably stood beside a car or beside a ball moving in the hallway at a constant speed with stopwatches timing. Start, stop, and everybody collected their data together, everybody put it together, and then plotted the graphs. Today what we're going to do is collect the data individually as groups, and we're going to do it electronically. The device that you see right here is called a motion sensor. It sends these little pulses of sound at 20 cycles per second, 20 pulses of sound per second outwards toward this car. They reflect off of this car and get detected back by the motion sensor, processed, and converted to a position and a time. Now, we can't read any data off of that motion sensor without using something else. That's why we use this device right here that we call an Airlink apparatus. That's what allows this motion sensor to do its thing. It's what gives it its power. It's what gives it its ability to transmit the data somewhere. This Airlink is going to be connected via Bluetooth to your phone. Now, your phone is going to require an app in order to use this. The app is called SparkView, and I'll get you to start downloading that app now because the Wi-Fi at the school doesn't always work the best, and it sometimes takes a little while to do that. If you've got an Android device, go to the Google Play Store. If you've got an iPhone, go to the App Store. Look for SparkView, V-U-E, not V-I-E-W, V-U-E, and start downloading it. It's free. Get that going now so that it can be downloading as we're talking about the rest of the lab here. You can see the other piece of apparatus here is the car. Now on that car, this motorized car is a piece of cardboard taped to it. You may or may not need to use this piece of cardboard. This cardboard is taped to the car in this case simply because sometimes the car doesn't seem to be big enough to be detected by the motion sensor. If you find that you try a trial and the motion sensor is giving you kind of, well, essentially random data, not predictable, recognizable data, then you might need to make your car bigger so that it can be seen better by the motion sensor. If it's already got cardboard on there, I probably wouldn't bother taking it off. If it doesn't have cardboard on there, don't panic about that. Try it, and if it gives you some decent data, then we'll leave it at that. If you need to make it bigger, make it bigger. There's a switch on the side of these cars. You're going to turn on the switch. You're going to let the car go away from the motion sensor. So the car is going to go this way, away from the motion sensor, as the motion sensor is turned on. There are instructions in these booklets up here as to how to turn on the motion sensor, how to use the app, and so on. You need to follow those instructions to the letter. They're not difficult. You just need to read the instructions. And if you don't understand something, then ask me. I'll help you. Part of the reason I'm getting you to read those instructions as opposed to feed them to you is because I think there's value in interpreting things yourself, as long as you have the ability to ask me questions when you don't understand something. I'll always help you, but you need to try it yourself by reading the instructions. So you're going to turn this on, you're going to turn this on, you're going to send the car away from the motion sensor at a constant speed, you're going to detect data, and then you're going to transmit that data to your iPhone, and then from your iPhone, you're going to email that data to your school account, to your school email account. And again, all the instructions for all of that stuff is in that booklet that you're going to get in just a few moments here. Once you've collected that data, once you've got that data emailed to yourself, it should look something like this. Time in one column and position in the next column. You're going to get a bunch of data, of course. And then once you have that, you're going to take that and plot a graph with it. Now, I'm going to tell you which variable to put on which axis today because you haven't done a lot of this before. In the future, you're going to have to know yourself which variable to put on which axis. Listen carefully. The first column of your table is always the manipulated variable. And the second column is always the responding variable. Always. The x-axis of your graph is always the manipulated variable. And the y-axis of the graph is always the responding variable. So we will, in this one, put time on the x-axis and put position on the y-axis. The title of the graph, by the way, will always be responding versus manipulated. So in this case, the title of the graph will be position versus time. When you plot that graph, not by hand, but by spreadsheet, and I'll show you how to do that. I'll demonstrate that to you once you guys actually have some data collected. I'll demonstrate for you how to plot the graph on the spreadsheet. You should get something that looks like this. Data points that are not perfectly in a straight line, but at least close. You will have your spreadsheet plot a line of best fit for you. You'll tell it to draw a line of best fit, and you'll tell it to find the slope of that line of best fit. The slope of that graph that your spreadsheet will spit out for you, as long as you tell it to do that, the slope of that graph will be the velocity of that car. So remember, the problem was to find the velocity of a motorized toy car on a flat horizontal surface. Once we get to this point, we've got the velocity of that toy car. It's simply the slope of the graph. Now, you've got a conclusion, which usually relates to your hypothesis, but we don't have a hypothesis here. So we're going to relate it back to our problem. We're going to answer our problem. What is the velocity of a toy car? The velocity of a toy car on a flat horizontal surface is blank meters per second, period. This is known. How do you know? How do you know that's the velocity of this particular toy car? Well, basically, it comes back to the graph, right? This is known because the slope of a position time graph represents velocity, and the slope of this particular position time graph gave me that value. So something essentially similar to that. Finally, we need sources of error. You guys have done this before in grade 10, maybe even in grade 9. Sources of error are things that could have been better in the lab. It could relate to the materials. It could relate to the procedure. It could relate to your time management, all kinds of different stuff. What it can't be is human error. What I mean by that is, don't say, Jack made a mistake. First of all, Jack's not going to make a mistake. Second of all, if he made a mistake, fix it. Fix the mistake. Don't say that's a source of error. Okay? Don't say calculation errors. Don't say I didn't really know how to plot the graph. Okay? Those aren't sources of error. Those are human errors. Sources of error are objective things, okay? Not things that you mess up on. They're objective things. Along with the sources of error, we need suggestions for improvement. So we need the source of error, and we need the suggestion to improve that source of error. Be specific. Don't say the apparatus wasn't very good. Suggestion, get better apparatus. Okay, that's weak. That's really general, and that's the kind of thing that people that aren't really thinking very hard about the lab come up with. That's not what we want. Okay, we want specific and good. If you come up with good ones, I can live with a couple sources of error. The worse they are, the more you better have. So if you're giving me things like the apparatus wasn't very good, get a new apparatus, then you better have 50 or so. I'm kidding. Just don't put that, right? Give me a better source of error than that. Okay? The better they are, the less you need. But I'd like to have at least 2 good sources of error, even if they're really bang on sources of error. So what do you got to hand in for this? What do you got to hand in? Well, you need the problem, although the problem I've already given you. So you're not going to get marked on that. I just want to see it there. You need your data, which is that table of time and position. You need your analysis, which is your graph that includes the line of best fit and the slope of the graph. And I'll show you how to do that once we have some data. You need your conclusion, which are those 2 sentences. And you need your sources of error, which includes what could have been better and how could it have been better. Now, there are some things that are conspicuously absent from this write-up. What are we missing from this? Yep. Hypothesis. What else? Variables. Manipulated responding control variable. We have variables, but we're just not listing what they are, right? What else? Materials, procedure, right? Why am I not making you do all that? Well, because I want the write-up of this to be quite simple. And the reason I want the write-up of this to be quite simple is because the way you're doing it is quite different than the way you've done things before. There's a learning curve involved in the technology here, right? In using the SparkView app with the Airlink apparatus, in transmitting data to your phone, in plotting the graph on a spreadsheet, and so on and so on and so on. Okay, I want you to learn that stuff. That's really handy to have, but I don't want you to get bogged down learning that stuff at the same time as you have to write up a crazy hard lab write-up. Okay, you'll have labs that are harder to write up than this, but by that time, the equipment and the software and so on that we're using, you're not going to have to worry about that because you're going to be pros at that, right? That makes sense? So this one's going to be a pretty easy write-up, but you got to learn a little bit to get to this point of writing it up. Okay?